Chapter 11, Practical Considerations for Digital Design. Flip-flop time parameters. We have the race condition and data manual. AC waveforms are illustrated measuring points. This is the race condition, figure 11-1. You have your RD, your set, your reset, and you have your clock pulse, CP, and you have your K value coming in here. And figure 11-2, you have your AC waveforms. They're illustrated by points with your IS and L. This little propagation between the J or K and your clock pulse. You got your trigger points as your VMs at roughly 1.3 volts. And the shaded areas indicate when the input is permitted to change for predictable output performance. Some time parameters for flip-flops we have are setup time, which is the time prior to active clock edge, TSL and TSH, high and low. We have hold time, high and low, and propagation delay, which is the delay from input to output signals. As you can see here, we have our TS and TH setup and hold times, and the propagation between the two. The manufacturer's data manual describes three basic functions. We have the maximum frequency, clock pulse width, and set or reset pulse width. You have the metastate table, the output voltage at any invalid level, and delay gate ICs to provide delay for propagation time delay. You have an automatic reset on some chips. This automatically resets at power up. You use the RC circuit as shown in figure 11-26. Here you have the RC connected up to your 7476 JK flip-flop. You have Schmitt Trigger ICs. There's a positive feedback to speed up level transitions. Hysteresis is a switching threshold of positive and negative going signals that are different. It's useful to ignore small amounts of jitter. This is shown with the jitter in figure 11-27. You could ignore that and correspond it to the lower waveform, which says it's either 1 or 0, and then the same with this one. It's either 1 or 0. And the Schmitt trigger has a voltage range with 0.9 to 1.7. This allows for the range to determine what's jitter and what's not. Switch debouncing is when a mechanical switch is opened or closed. You can see that from figure 11-38 is when the switch position is either on or off, and it bounces, and you have the following output determining with the clock pulse whether it's on or off, but it's very straightforward with the 0 and 1 again, so it eliminates the bouncing method. And you have the JK flip-flop and the Schmitt method as well. This is the JK flip-flop method with the same type of deal, and the Schmitt trigger method that takes away the bouncing as well. Just correlates it to a 1 or a 0 value instead of many different in-between values. We also have a cross NAND method and D flip-flop method. The cross NAND method is your two NAND gates, and the output of the first NAND gate goes into the input of the second, and the output of the second goes into the input of the first, and vice versa. This again has its jittering with the reset and the set command, but that just changes into a 0 and 1 value. Sizing pull-up resistors. These are used to prevent floating. They avoid high power consumption, and approximately a 10k ohm resistor works just fine. And a pull-down resistor, different type, is to keep a terminal low, and a 100 ohm resistor works for this optimal value of a pull-down resistor's function. Practical input and output considerations. Usually use a 5 volt power supply with a 60 hertz clock, which is a Zener diode you use that for. With the Zener diode, it regulates the clock right here into the Schmitt Trigger 7414. Some more practical considerations is driving light emitted diodes. These provide current by syncing when output is low, 330 ohm resistor to limit current, and connecting multiple I/O to a CPLD device. Phototransistors, input into a latching alarm, and using an optocoupler for level shifting. And these are other examples of going into a CPLD circuit. And this is another high-powered Schmitt trigger going into your D flip-flop. And this is your optocoupler type of circuit. There's also power MOSFET uses to drive a relay and level detecting with analog comparator, such as the LM339. This is described here, the LM339 to the piezo buzzer alarm. So in summary of this chapter, you can say that the flip-flops have various levels of time propagation. We have setup time, we have hold time, we have propagation delays, the length of time it takes for the output of a logic circuit to respond to an input stimulus. Delay gates are available to purposely introduce time delays when required. The charging voltage on a capacitor in a series RC circuit can be used to create a short delay for a power-up reset. There are two key features of Schmitt Trigger ICs that they output extremely sharp edges, and they have two distinct input threshold voltages. Pull-up resistors are required to make a normal floating point input act like a high, and pull-down resistors are required to make a normal floating input act like a low. And a practical, inexpensive 5 volt power supply can be made with just a simple transformer, 4 diodes, some capacitors, and a voltage regulator. And a 60 pulse per second clock, 60 hertz clock oscillator can be made using the power supply's transformer and a few additional components. An optocoupler provides electrical isolation from one part of a circuit to another.